Okay, so in the past videos, I showed you how to solve the roots of a quadratic equation, where the quadratic itself wasn't a factorable quadratic. And we did that through a method called completing the square. And now, it would be nice if we could derive a one-size-fits-all kind of formula that can solve for the roots of any kind of quadratic equation. So the way we're going to do that is, first we're going to have to write out the quadratic equation in its general form. There we go. But here, of course, we're going to have to represent all the coefficients of x squared, x, and the constant as a, b, and c, respectively. Alright, so here we have ax squared plus bx plus c is equal to 0. So the next step, to derive our one-size-fits-all kind of formula, we're going to have to do the same method we did before, which was completing the square. Well, it would be preferable if x squared right here didn't have a as the coefficient. It would be preferable to have x squared all by itself, just like that. Okay, so how do we do that? Well, we can divide by a, the coefficient of x squared. What are we going to get? We're going to get x squared all by itself. And here we're going to get b over a multiplied by x. And here we're going to get c over a. And that is equal to 0. Okay, so the next step in completing the square is we need to move this to the other side. Okay, so when you move it to the other side, it's going to become negative c over a. The sign will flip. Alright, so here, I'm still going to write out x squared plus b over a multiplied by x. And then I'm just leaving a space here and here because we're going to have to write something there. So we're going to have to find a term that we can fill this space up with. This and this space. So how do we find that term? Well, from our last video, I showed that we can take the coefficient of x, which is b over a, right there. I'm going to write that here on the top. Hope you can still see that. And then we're going to divide that by 2, and then we get the square of that. And that is the term that we need to fill these spaces up with. Alright, so what are we going to get? So I'm going to have to do the inside first. So we're going to have b over 2a on the inside. And then we still need to square that. We're going to end up with b squared over 4a squared. So that is the term that we need to fill up these blanks with. So we have b squared over 4a squared. Then same goes on the other side. All right. So what is the next step now? Well, you can see that we have lots of fractions in both sides of the equation, and we don't ever want to deal with fractions. So to get rid of the fractions, we just multiply everything by the least common denominator, or the LCD, which is 4a squared. There we go. Okay, so what happens now? So on the left side, we're going to get 4a squared x squared, and here we're going to get 4abx. And then here we're going to get b squared, just b squared by itself. Here we're also going to get b squared. And here we're going to get 4ac. And there we go. Alright, so now we just got rid of the fractions. And what do we need to do now? Okay, so now on the left side, we now have a perfect square trinomial, which is this, the whole thing. So we can write that now as a square of a binomial. Then I'm just going to copy whatever it is on the right side. And what can we write here inside the parentheses? Well, this is just a binomial, which is the square root of this. So I'm going to have to write 2ax plus b. There we go. And now, what is the next step? Well, we're going to have to get rid of this square right here, because we want to isolate x. We're going to have to square root both sides. So what do we get? So here, this and this, they are going to cancel out. So here we just get 2ax plus b without the square. And here, we're going to get plus minus square root of b squared minus 4ac. So remember guys, we need to have a plus minus symbol here because we are considering both positive and negative roots of this radical term b squared minus 4ac. And that is because the quadratic equation will always have two roots. So we're not going to get two roots if we only have one sign for the square root term right here. Okay, so I hope that clarifies that. Okay, so next step, we're going to move this b to the right side. So that's going to become a negative b. And here I'm just going to copy this. Plus minus square root of b squared minus 4ac. And here on the left side, we're going to have 2ax. And guess what? We can just divide the whole equation by 2a to isolate x on the left side. So here we're going to get minus b plus minus b squared minus 4ac all over 2a. And there we go. This is our magic one-size-fits-all kind of formula that we can use to solve for the roots of any kind of quadratic equation. Alright people, so before we end this video, let's do one example where we actually solve for the roots of a quadratic equation using the quadratic formula that we just derived. So here we have the quadratic 10x squared minus 14x minus 12. Okay, so let me rewrite first the quadratic formula. So that's going to be x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. There we go. So before you do anything, you need to identify what our a, what our b, and what our c are. Okay, so for our a is just going to be 10 right here. So I'm going to write here a is equal to 10. And for b, remember that we also need to include a negative sign. So we have minus 14, so b is going to be equal to negative 14. All right. And for our c, we have a minus 12, so c is going to be equal to negative 12. There we go. So next is we just have to plug these values into our quadratic formula. So let me write this down. So we have negative b here, but instead of putting b, I'm going to put a parenthesis, because that helps just in case our a, b's, and c's are negative. So here we have b squared. So here we have 4ac. And here below we have 2a. Next is we plug b into here. So b is going to be equal to negative 14. And here it's also b. That's negative 14 there. And here we have a is equal to 10. And here we have c is equal to negative 12. And below we just have a, so that's going to be 10. There we go. Okay, so for the next step, we just need to simplify the expression. So here we have negative minus 14, so that's a double negative. That becomes positive 14 there. And here we have negative 14 squared. What is 14 squared? That's 196. And here we have a minus sign and another minus sign, so this sign will be positive. And that leaves us with 4 times 10 times 12, and that is going to be 480. And then below we just have 2 times 10, so that's going to be equal to 20. All right. And here we just simplify further. So we have 14 plus minus square root of 196 plus 480. So this is going to be 676. And below we have 20. So what is the square root of 676? That's going to be 26. And now we can now split the equation into two parts. So on the left side we have x is equal to 14 plus 26 all over 20. And on the right side we have x is equal to 14 minus 26 all over 20. And there we go. So here, what is 14 plus 26? 14 plus 26 is just 40. So that's over 20. Here we have 14 minus 26. That's going to be equal to negative 12 all over 20. So here on the left side, we have x is equal to 2. And on the right side, we have negative 3 over 5. And there we go. Now, one root is equal to 2. And the other root is equal to negative 3 over 5. All right, there we go. So let's go back to our original quadratic and let us check if we get the same result if we factored our quadratic instead. Let me rewrite the quadratic again. So we have 10x squared minus 14x minus 12, and that is equal to 0. And here we have a 10 as the coefficient of x squared, and the constant being negative 12. So 10 multiplied by negative 12, what are we going to get? We are going to get negative 120. All right, so we need to think of factors of negative 120 that will add up to negative 14. What are they? So I think we can do negative 20 times 6. I think that is going to work, because negative 20 plus 6 will give you negative 14. Okay, so here I'm going to write the equation all over again, but this time I'm going to split the negative 14 into minus 20x plus 6x, and then just copy the minus 12 and the equal to 0. And here we're just going to factor out their greatest common factor, which is 10x. So this is going to be x minus 2. And here, the other one is just going to be 6x minus 2. That's equal to 0. And here we have 10x plus 6 multiplied by x minus 2. There we go. So one side of the equation, we have 10x plus 6 is equal to 0. And on the other side, we have x minus 2 is equal to 0. And here we have minus 6 over 10 is equal to x. So x here is equal to minus 3 over 5. And here on the other side, we have x is equal to 2. So we just got the same result, guys. One root is 2, and one root is negative 3 over 5.